On to the third page. Question 8 gives us this triangle ABC, and it asks us three different questions, part A, B, and C. And each time we're starting with A, B, and C, and they're asking us to describe where one of the coordinates goes after a given rigid transformation. The first one is, what if we took this and rotated it 90 degrees about the origin? Now, there's definitely a rule about, and by the way, it was rotated at 90 degrees clockwise. There is definitely a rule that maps a 90 degrees clockwise rotation, and I believe the rule is this: you take the xy of the point that you're given, and if you're rotating 90 degrees about the origin in a clockwise fashion, I believe it goes to y and then the opposite of x. So, what is your what is your x value when you take the opposite sign of that? It becomes the y, and what is y just jumps up in front and it becomes your x value. So if you look at this for part A was at -4, -2. It was at -4, comma, -2. And if I subject that to this rule, again, what does it say? It says, what is x? Take the opposite of that, and that becomes y. So y is going to become a +4. And what is y? Put that up in front. That's going to become x. So what was y was it? So this should be, so it should go to -2, 4. And of course, I've got this all set up in my favorite free software, GeoGebra. Get it at geogebra.org. And I want to quickly, k right here is any arbitrary angle that I want it to be, and I can set k equal to 0. I hope I can get close to 0. I think that's as close as I can get right now. I'll just put it there, and then I'm going to turn on this polygon that will be transformed by that angle. So here it is, and you can see it, right? I can make it go counterclockwise where it's a negative values, and I can make it go clockwise. So because it was a clockwise rotation, positive angles are making it go this way. And let's just track what happens. Here you can see where A starts, and if I go through 90 degrees, right, as I get closer and closer to 90, and there it is. It's right. Oh, it's right there. If I could just get my pen to go away. Well, that's close. But you can see, yeah, I'm exactly at the value x is -2 and y is 4. And at that point, x is 2, y is 4. That's where point A goes to. So this is now A prime, right, after that transformation. So, yeah, let's go and write that down. So this is going to go to -2, comma 4. The next one I think is a lot more simple, right? Part B says if triangle ABC is reflected across the y-axis, so here's my y-axis, this is going to be the thing that I reflected across. Give the coordinates to form triangle A prime, B prime, C prime. Give the coordinates of B prime. Well, I can see where B is, and if I was to reflect that across, it's going to go over to +3, 1. So this right here, I'm just reflecting this whole thing. And by the way, the A would be, where would A go? A would go to here. So I can see this triangle now. This is it right here. The important thing is where is B at? B should be at 3, 1. So it should be x is 3 and y is 1. And then the final question says, hey, there's a translation rule. And I can see I've got my point x, y, and they're going to get mapped. I'm going to be increasing the x value by -4, or I guess I should say I'm decreasing x by 4, and I'm increasing y by 7. So if I'm going to track point C with this rule, I guess I'll do it with this blue pen. So here's where C is, and I'm going to have to go back 4 units for x. So it's going to be 1, 2, 3, 4 units back. And then I've got to go up 7 units. So that's 1, 2, 3, 4, 5, 6, and 7. Boy, these are small numbers, right? So if I look at this at the end, we've got that x should be at -4 and y should be at 3. So this is the point right here where it would go to after I did that mapping. So let's write that down. C is going to go to -4, oops, and then to 3. All right, question 9. So 9 says solve each equation, system of equations, or inequality. Clearly communicate your solution. So if answers just magically appeared here, I was likely to take off points, right? I don't think answers should ever magically appear. So in this first problem, I'm looking at it, I think this is a clear candidate for substitution, and I think most of you picked that. You're looking at this thing that I'm putting in parentheses and saying to yourself, that is y. So I'm going to substitute that in for y in the equation above. So I write the 2x, and then I need to subtract y, and y is x minus 7. Now, perhaps I saw a few errors here that I don't know if the parentheses weren't used or what happened, but um, I'm subtracting this, so I need to make sure I'm distributing this negative sign across this binomial, right? Both of those are going to flip their signs. So this is going to become a 2x and then a minus x, and then it's going to become a plus 7. So you see how that worked, right? I'm subtracting negative 7. And then over here it equals 9. So if I combine these like terms, this says x plus 7 is 9. If I take away 7 from each side, I get that x is the number 2. So I now know what x is. X is 2. And if I just plug this value of x into the original problem, right, if I plug it in right here, I could figure out y. Y would have to be the value of x I just found minus 7, which would mean that y has to equal negative 5. And of course, our solution should be written as an ordered pair because the solution to a system is an ordered pair, right? So I'm going to write this as x is 2, y is negative 5. There's our solution. Let's jump over to part B. B has this linear inequality, and it says that this absolute value is less than, it's constrained by the number 14. So it has to be inside of this bubble where it's 14, right? It's not going to bust out of it, so it has to be less than that. And when we have a less than statement, right, we can lose the absolute value by breaking it up into an and statement, right? So it's and, it has to be two properties inside between these two things, and one of them I'm just going to write this is exactly as it occurs, right? 3x minus 7 is less than or equal to 14. And on the other side of that, I'm going to write the 3x minus 7, and I'm going to flip that to greater than or equal to, and then again, here it's going to be a negative 14. So I'm considering the two things, right? The thing inside is either less than 14, or it would be greater than negative 14, in which case that and statement would be true and it would be inside. I I think we've talked about it, but I was confused by the number of times people didn't flip the inequality symbol. So remember the thinking here. If I have a statement like 2 is less than 5, that's clearly true. And if I multiply both sides of that by negative 2, for example, that would make this a negative 4, and that would make this a negative 10. Well, as I look at those, I have to say to myself, well, which one's smaller now, right? Or which one's larger now? And it flips, right? Negative 10 is clearly less than the 4. So negative 4 is greater than negative 10. So you can see when I multiplied both sides by this negative value, it necessitated a flipping of the inequality's direction. And that's what happens exactly here, right? When I consider this negative case, I have to break it. I have to flip the direction of that inequality. So I've taken the absolute value and I broke it down into two cases, and I solve these separately, individually, and the solution steps are the same, but because I'm starting with negative 14 on the one hand and a 14 on the other, the solutions will be different. So be careful with this. So let's start with the one on the left of the and symbol. I'm going to add 7 to each side first. When I do that, that's going to become 3x is greater than or equal to the number negative 7. So if you look, I had a negative 14 and I added 7 to both sides. I added to the side with the 3x and I added to the side with the negative 14. And I'm just going to divide both sides by 3. So x's are those things that are greater than or equal to negative 7/3. So this is our lower bounds. X has to be bigger than this. And It's not enough, right? It has to stop at some point. It can't go on forever because it'll exceed that 14 boundary. So on the other side of that, we're going to add 7, and we've got 3x is less than or equal to 21. That's just adding the 7 to both sides again. And now when I divide by 3, I can see that I get that x is less than or equal to 7. So yes, it starts at negative 7 thirds, if I was to look at this on a number line. And that's like, what is it, negative 2 and 1/3. So here's 0, 1, 2, 3. So that's at about 2 and 1/3. It's a solid dot. It starts there and it continues until 1, 2, 3, 4, 5, 6, 7, until it reaches the value 7. At which point it has to terminate there. So my x values are all those numbers that live in between these. So these are all x's that will work, including 0, 0, right? If I was to put 0 into the original inequality, it would definitely work. In fact, negative 7 is what would be inside of the absolute value. The absolute value of that is 7, and sure enough, 7 is less than 14. Things that are outside or beyond the reach of that, like 8, for example, they won't satisfy the inequality. And if things are less than this negative 7/3, they won't satisfy it either. So, by the way, with an and statement, it is possible to combine these into one inequality. I can write this. I've got 7/3, and then I've got the x's, and then I've got a 7. Please notice that the 7/3 and 7, if the x was gone, not in this statement, this is still valid, right? Negative 7/3 is, this is true. When you write an inequality and that's not true, when you take the variable x out, that's kind of a problem. And I saw that on a couple of your, I think it was part D where I saw that. Okay, so number one error right here was C. It has to do with multiplying the binomial, right? Because perhaps you didn't multiply the binomial correctly in the previous problem, right? You just looked at this as, for example, 4x squared plus 1. I think a lot of you replaced it with that. That caused issues. So remember, this is not, this is a binomial, right? It's a 2x plus 1, and let me generic area model this, and I'm multiplying it by a 2x and a plus 1. So there's 4 distinct regions in this area model. One of them is 4x squared. Here's a 2x, this is 2x, and then this is 1. So a replacement for that, right, to get rid of the parentheses would be 4x squared plus 4x and then plus 1. I still have this minus 3x, and that equals 4x squared on the other side of the equation plus 8. What's very nice is the fact that both of these have a 4x squared, and I'm going to quickly subtract that from each side. And at the same time, I'm going to go ahead and combine the 4x and the negative 3x. So I now have a x plus 1 equals the number 8. And if I subtract 1 from both sides, I get that x is the number 7. Now, not only does it seem like this should work, this does work, right? And if you took the time to plug in any other answer, you would have noticed that it did not indeed make both the left hand and right hand side the same. 7 will. 2 times 7 is 14. 14 plus 1 is 15. I have no idea what 15 squared is. Why did I start talking about checking this if I didn't know that? 15 to the second power. Whoa, 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 whoa. Let's to the, there's 15 squared. And then I need to subtract 3 times 7. So I'm going to subtract from that. I'll hit minus and then 21. So on the one side I get 204, right? So this became 204. I should get the exact same thing on the other side, so let's try it. So it's 4 times 7 squared. 4 times 7 to the second power. Let me leave the exponent and I'll add 8 to that. Doop, 204. So this is exactly the value, right? 7 makes both sides of this 204. It is the solution to this equation. All right, and then the final part on this page, final part of this question and the final question on this page is D. And this says that the absolute value of something is greater than the number 7. So it's not contained in a little region. It's shooting out to the left and right because it's larger than 7. It's 7 or more than that. Oh no, it's not. It can't be 7 or more than that. It has to be strictly bigger than 7 because it's not or equal to. So same exact technique, except this is not going to be an and statement because it's not stuff contained inside of a zone, right? This is stuff shooting out to the left and right. So this is going to be an or. This is greater. And again, I'm just going to write on the one side 5x minus 2 is greater than 7. That's exactly as it looks, just minus the absolute value part, right? I omitted that. But to truly get rid of the absolute value, I have to consider the other case, right? The other side of that. So I'm going to write the 5x minus 2, and I'm going to say that that has to be less than negative 7. So you can see now I've taken the opposite of that, right? And I had to flip the direction of my inequality at the same time. So, um, however, I was quite sloppy, and I put this as this should be a minus a 2. All right, so let's look at this first part. I'm going to add 2 to both sides, so I get that 5x is less than, let's see here, if I add 2 to both sides, it's going to become a negative 5. And if I divide both sides by 5, I get that x has to be less than negative 1. Okay, x's are smaller than negative 1. In fact, if I looked at a number line, here's 0, here's negative 1, and we're saying the x's, they can't be negative 1, right? That's just the beginning of it, but they're everything that's smaller than that. So all of these values are my x's on the one side, and this is joined by the or. Let's look at the other side. I'm going to add 2 to both sides, so I get, again, 5x is now greater than 9, and if I divide both sides of that by 5, I get x is greater than 9/5. So here's 0, 1, 2, 3. I think that's like it's like 1.8. So 1.8 approximately here. Let me do 1, 2, 3. About 1.8, but not including 1.8. And then it's everything this direction. So I can tell by looking at this, if I put 0 into this original problem, it will fail miserably, and 1, like, this will be a failure, 1 will be a failure, anything in that zone will be a failure. Um, so for example, if I put in 0, that becomes negative 2. Absolute value of negative 2 is 2. 2 greater than 7? Are you kidding? No, 2 is not greater than 7. So see, I told you it was going to be a failure. It did not work. It did not satisfy the inequality. Anything outside of it, right, shooting out and it's greater than this either direction will work, including the number 5 or 3 or negative 10. All right, so that's the end of page 3. Almost done. One more page to go.